Hello. So let's discuss component vectors. Okay. Now, first, let's have the rectangular component. Okay. Rectangular component in the sense that your reference, or you will draw a Cartesian plane, rectangular Cartesian plane like this. Okay, you have the x and y. Okay, for example, you have here a vector, a single vector. Okay, like that. Let's call that vector A. Now, when you say component, these are, you could split. Okay, these are parts of the vector A. Okay, let me put an arrow there. So, part of vector A. To have a component, your reference is this is x and y. Okay, again, this is for rectangular. Now, to make a component, all you need to do is to, this is the y-axis, and this is the x-axis. Okay, x and y. Of course, you have positive to the right. Going up is positive. Going down, y is negative. Then this is negative. Now, to find for the component, all you need to do is to draw a parallel line from y until this point. That is parallel line. Okay, like that. Then parallel line from x to that point. Okay. Again, it quite, shall I say, confusing or parang tempting that this is perpendicular. Okay. Of course, in the drawing, it's perpendicular. But, if you have an oblique coordinate system, you will have a problem. So, at the start, don't say that this is perpendicular, so that you will not be confused. Now, what you will do is to make a parallel line from x, parallel line from there. So you have here that line, okay, this line, and the y parallel line, and you draw like that. And the component would be this one. You'll have to draw, okay, like that. Okay, this is AY and this is AX. They are both positive. Now, this blue AY and AX are component of A. So they are not different vector. Actually, they are the blue one, AY and AX, are component of Y. Okay, so let me put it this way. Okay. A while ago, we have the A vector. Now, this A vector is the same as this vector, component vector AY, okay, and AX. So, that's what we call the component vector. Now, take note, this is very important if we are computing for resultant later on. So, you have to be familiarized with this. Okay, especially the positive negative sign. Now, another one, okay, is if you have, okay, your vector, let's say vector B is this one, vector B, okay, so that is vector B. Now, to find for the component, of vector B, component y and x, all you do this parallel line from x to there, okay, should be parallel, then y to this point, okay, then you can now draw the by and bx. This would be positive by, and this would be negative y because it's going to the left. Again, these blue are component of B, vector B. So they are not three vectors. They are the same vector. Okay? So we are just splitting the vector B so that later on we would have a very easy computation. Okay? Similar to this one. In this case, we have different direction, and the direction is also important. So you have to take note of that. Now, again, let's make another vector, and let's put that in quadrant 3. This is quadrant 3. Let's call this vector C. Okay? So, vector C, like that, C. Okay? Now again, parallel line from X, this is Y, so you have that parallel line and this one. So this would be CY, and that is negative, and you have CX, and that is negative. So they are both negative. So I hope that is clear. Now we could also have another vector, and in this case it's in vector or in quadrant 4. So this one. Okay. So this is, let's call that vector D. And again, parallel line. Okay, parallel line. Then you have this one is dy, and that is negative because it's going down. And to the right, that is dx, that is positive. So that is a rectangular component of vector. Okay, so again, that is very important. Now, there are instances that the coordinate or the x and y are not rectangular, they are oblique, meaning like this one. The rectangular is this. Okay. It's rectangular. Now, there are instances that my coordinate is like this. Okay, I have now okay, like that, and like this. I have let's call this y prime. No, let's call this x prime, and this is y. Okay, then you can note that this is positive and this is negative. So negative, positive y. Okay, then my vector is let's say my vector is this. Okay, vector E. Now, what is the component vector of E with respect to x prime and y? So how do we do that? Again, if you are familiar or your training is perpendicular, that would now be a wrong component because your component would be like this. So like that and like that, then that is not a component of E. Now what I told you is that you have to make a parallel line, okay, from here and y parallel line there, and in that case you will not have a problem with the component because your component from x prime is this one. Okay, so you have e y prime. And the other one, what's the other one? Is oh sorry, this should be x, sorry. Should be x. The other one is y, and along y until that point, is that correct? Sorry. Ang ganun pala. So until that point. Okay? So it would be e y. That is positive and that is positive. You have the component ey of e. Now take note, if you notice, it forms a parallelogram. And if this is parallelogram, okay, later on, if you remove the e and get the resultant or the vector ey and ex prime, you will get the e. So they are the same. I mean, ey and eyx prime, if you combine them using the parallelogram method, you will end up with e. So this one is the same as there. So that is the difference between you have oblique and you have the rectangular. Of course, we seldom use this oblique, but you will use it. So this is the most common that we will be using. Now let's have another example so that you will remember. For example, what's next? Okay, let's make it like this. This is x and this is y. So let's call this negative, that's positive y, that's positive x, this is negative x, and our vector is let's say this one. Okay, let's call that vector f. Okay, vector f. Now what you will do is to find you have to do a parallel line from here to there. Okay, then a parallel line from x to here. Then again, they are not perpendicular na, unlike sa rectangular, but a parallel line. So you have this ey. Okay, sometimes they call that prime, but it's just a notation. And this one is ex. So again, you will form a parallelogram. So remember that it will be useful, especially in your engineering mechanics. So that's it for today. So again, we discuss component vector. We'll be using the component vector to solve later on resultant of many vectors.